The DDG-1000 Zumwalt-class multi-mission destroyers, currently being built by General Dynamics Bath Iron Works for the US Navy, are the world's biggest ever destroyers with a full load displacement of 15,656 t. Each Zumwalt-class destroyer has a length of 186 m and width of 24.5 m and can complement a crew of 158. The advanced surface combatants are equipped with stealth features and can conduct littoral operations, as well as anti-air, anti-submarine and anti-surface warfare missions sailing at a speed of 30 km. The vessels are armed with an 80-cell vertical launch system, VLS, two 155mm advanced guns, and two 30mm close-in gun systems, CIGS. Critical technologies such as an all-electric integrated power system and a damage control system are also incorporated into the vessel. Aviation facilities aboard the vessels include a large flight deck and a hangar. The Zumwalt-class, DDG-1000, is the largest and most technologically advanced surface combatant in the world. USS Zumwalt is the lead ship of a class of next-generation multi-mission destroyers designed to strengthen naval power from the sea. The Zumwalt-class destroyer performs a range of deterrence, power projection, sea control, and command and control missions while allowing the Navy to evolve with new systems and missions. Stealthy, powerful, and lethal, the Navy created the Zumwalt-class to bridge from current needs to future capabilities, adding space and power accommodating systems not yet imagined but designed to counter adversaries that challenge us now and in the decades to come. Designed to combat the threats of today as well as those of coming decades, these ships are equipped with numerous advanced technology and survivability systems. DDG-1000 is the first US Navy surface combatant to employ an innovative and highly survivable integrated power system, IPS. Key design features that make the DDG-1000 IPS architecture unique include the ability to provide power to propulsion, ship service, and combat system loads from the same gas turbine prime movers. DDG-1000's power allocation flexibility allows for potentially significant energy savings and is well suited to enable future high-energy weapons and sensors. The wave-piercing tumble-home hull design has facilitated a wide array of advancements. The design also allows for optimal manning with a standard crew size of 197 sailors, thereby decreasing lifecycle operations and support costs. DDG-1000 employs active and passive sensors and a multifunction radar, MFR, capable of conducting area surveillance, including overland search and track, throughout the extremely difficult and cluttered sea-land interface. It is also advantageous to install weapons systems such as railguns that consume large amounts of electricity. Information and communication technology systems can be used for automation and networking. The Zumwalts use an integrated power system, IPS, a modern version of a turboelectric drive system. The IPS is a dual system, with each half consisting of a gas turbine prime mover directly coupled to an electrical generator, providing power for an electric motor that drives a propeller shaft. The system is integrated because the turbo generators provide electrical power for all ship systems, not just the drive motors. The system provides much more available electrical power than is available in other types of ships. The Zumwalt-class has no anti-SBG 62 fire control radars, which are used for terminal guidance for standard and evolved Sea Sparrow missile, ESSM, anti-aircraft engagements. The SPY-3 will generate interrupted continuous wave illumination, ICWR, rather than the continuous wave illumination of the anti-SBG 62 fire control radars. The Mk-57 Peripheral Vertical Launch System, PVLS, is an attempt to avoid intrusion into the prized center space of the hull while reducing the risk of loss of the entire missile battery or the ship in a magazine explosion. The system consists of pods of VLS cells distributed around the ship's outer shell, with a thin steel outer shell and a thick inner shell. The design of the PVLS directs the force of any explosion outward rather than into the ship. Additionally, this design reduces the loss of missile capacity to only the affected pod. 2 spots are available on a large aviation deck with a hangar capable of housing 2 full-size SH-60 helicopters. Boats are handled within a stern-mounted boat hangar with a ramp. The boat hangar's stern location meets high sea state requirements for boat operations.